And we are moving along with inequalities with video 3.4. We're going to learn how to graph inequalities. This will not be graphing on a number line. This will be actually graphing on a coordinate plane, much like we graph linear functions. So get ready to take some notes and draw some graphs. So you need to write down the rules for graphing an inequality. Inequalities are graphed just like other functions, but there are some specifications that we have to follow in order to make sure we can see the entire solution. So much like the or equal to symbol changed the circle on the number line when we graphed, depending on the sign, it depends what kind of line we draw. So if it's or equal to, it's a solid line on the graph, and that shows that the line is included in the solution. Solid like that. If it's just greater than or less than, not equal to, it's a dotted line on the graph to show that the line is not included in the solution. You'll see examples of both of these. The next thing you have to do is to shade to show the entire solution. So if it's greater than, you'll shade above the line, and if it's less than, you'll shade below the line, but there's a way that we can check to ensure that we're shading correctly. So you have your steps right here. Very important to write them down. And also make sure you draw a coordinate plane in your notebook. And we have this inequality, y is greater than 2x minus 3. Now let's just go back to y equals mx plus b real quick. Remember that m is your slope, and b is your y-intercept, and that's how we can graph. So I'm going to start at my y-intercept of negative 3. I'm going to do step 1, plot my line, plot your line. So start at negative 3, and then I have a slope of positive 2. I'm not even going to pay attention to this inequality sign right now. I can just pretend that this says y equals 2x minus 3. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then I'll go backwards as well. And then step 2 says to connect points with the correct type of line. Now, remember from the slide before, if it was just greater than or less than, it's a dotted line. So I have to connect my dots with a dotted line just like this. And that proves that all the points on this line will not make this inequality true. They are not part of the solution. Now I have to shade in the direction of my solution. So this is y is greater than, so I have to shade up the y-axis, because all of this space over here, all of these points forever to infinity in this direction are going to make this inequality true. And everything below the line is false. It won't make the inequality true. So all you have to do to shade is draw lines like this, and it shows your solution. Now this may be confusing, why are we doing this? But this shows graphically the solution to a linear inequality. And step 4 is very, very important to always do. You have to check your solution to make sure you did it correctly. So how you do that, you can pick any point in the solution, any point over here. I always think that 0, 0 is the easiest point to use, because zeros just cancel everything out. So how you check is you pick your point. So I'm going to pick 0, 0. And then I just plug those values into my inequality. So I plug my y and my x, and they both happen to be 0. So 0 is greater than 2 times 0 minus 3. 0 is greater than negative 3. And that's true. So we did this correctly. We shaded in the correct direction. So you see how the point in the solution, 0, 0, makes this inequality true? Every single point here will make this inequality true. None of these points from the line down will make the inequality true. So you know you shaded correctly if when you check, it makes the inequality true and it's in your solution. And if you still want to use 0, 0, but it's not in your solution, you can still use it to check, and if it makes the equality false, and your solution is going the other way, you know you did it correctly as well. So let's do one more example. So I see a problem with this inequality to start with is that y is not isolated, so I'm going to have to divide by negative 2 to isolate my y variable, but I just divided by a negative. So remember, I have to flip my sign, so I get y is less than negative 1/2 x plus 4, because I divided 1x by negative 2, negative 1/2. I divided negative 8 by negative 2, it's positive 4. So I'm going to do step 1, which is to plot my points. I'm going to start at positive 4, that's my y-intercept, and I'm going to do a slope of negative 1/2. And now my inequality sign is less than or equal to. Because of that or equal to, it means my line is included in the solution, and I'm going to draw a solid line. And if this wasn't an inequality, that would just look like the graph y equals negative 1/2 x plus 4. And you guys all know how to do that. The tricky part about this is remembering all their steps. So we already did step 1. We did step 2. Now I have to do step 3, which is shade. Step 3 is shade. I have less than or equal to, so I need to shade down the y-axis, So I'm going to shade everything below that line. And so we did that. And now we need to do step 4, which is check. So I see 0, 0 is in my solution again. I can use that to check. I'm going to plug in 0, 0 to my, let's do the original equation. So negative 2 times 0 is greater than or equal to 0 minus 8. That's 0 is greater than or equal to negative 8. That is true. That's correct. So we know we graphed correctly because our solution checks out. I know that that's a lot of steps to remember, and it's a long process to go to, but if you can just remember to take your time going through each of the 4 steps, you'll be able to graph these and it'll become more natural to you, and you'll be able to remember the steps the more you practice. So I want you to graph this inequality here in your notebook and tell me if the point negative 2, 1 is a solution to the inequality. So once you graph it, tell me yes or no in your hot question that the point negative 2, positive 1 is in the solution to the inequality. And if you have any questions, please write them down. We'll go through this tomorrow.